You have here an equation. It says x cubed plus x squared plus x equals x times the square root of the difference of x and 1 over x divided by m times x plus 1 over x. So what are they asking you here? To isolate m. What is m in terms of x? Can you tell? It has to be one of the 4 answer choices. Okay, you can try. So what's the idea here? Okay, don't get lost in the many times the expression x appears. X appears so many times, 1, 2, 3, 4, 5, 6, 7, 8 times. So if you are thinking of perhaps applying a cross product, like multiplying all of these plus this times this, then that could be just, complicating things. Just think about the whole expression as something like this. Imagine that this is simply something like A, and this here is something like B, and this here is something like C. So what do you have? You have this A equals C over M times B. If I tell you isolate M, what do you have? Isn't it true that you just do this? Oh, this is A times M times B equals C. So easy. M equals C over A times B. And that's it. Because neither expression A, C, or B contains M, right? They are all based on X only. So I can do this. What is C? C is this part, X times the square root of X minus 1 over X. So I take a look at the answer choices. Which one contains only this expression in the numerator? I see that this one here. What about A and B multiplying in the denominator? That is x cubed plus x squared plus x times x plus 1 over x. Is this one. Here is your A, here is your B, and here is your C. So this is it. Option D. I didn't actually need to develop or expand, for example, the multiplication of n times x plus 1 over x. No need to multiply those terms. Just try to visualize that sometimes big expressions, they are just big, but they don't affect how we calculate a variable, how we isolate m in this case. It is much better to do this trick in order to avoid complicating ourselves with the detail of the big expressions.